Hello all, in this video I will be discussing on text parsing steps in NLP. So before going into the topic, let's look at some basics. Natural language processing is the ability of a computer program to understand human language as it is spoken and written, referred to as natural language. We know that NLP has gained a lot of traction as a subfield of artificial intelligence. It is focused on enabling computers to understand and process human languages. Some common applications include chatbots, sentiment analysis, translation, spam classification, and many more. However, there is a significant difference between NLP and traditional machine learning tasks, with the former dealing with unstructured text data while the latter deals with structured tabular data. Hence, it is necessary to understand how to deal with text before applying machine learning techniques to it. This is where text parsing comes into the picture. So, text parsing in simple terms is a common programming task that separates the given series of text into smaller components based on some rules. Its application ranges from document parsing to deep learning NLP. There are some rich functionalities available within Python to do text parsing. So the important steps in text parsing are tokenization, stopword removal, stemming, lemmatization, parts of speech tagging, chunking, and syntax parsing. We will look at each of these topics. First, tokenization. Before processing a natural language, we have to identify the words constituting a string of characters. Tokenization is said to be dividing a large quantity of text into smaller fragments known as tokens. These fragments or tokens are pretty useful to find the patterns and are deliberated as the foundation step for stemming and lemmatization. The token occurrences in a document can be used directly as a vector representing that document. In NLTK, the function where_tokenize is used for word tokenization and the send_tokenize function is used for sentence tokenization. As we can see in the below example, when we apply word tokenization to the sentence, we get each word as the output. Where when we apply the sentence tokenization to the sentence, we get each sentence as the output. Next step is stopword removal. Stopwords are a set of commonly used words in any language. For example, in English, the, is, and such words would easily qualify as stopwords. In NLP and text mining applications, stopwords are used to eliminate unimportant words, allowing applications to focus on the important words instead. But some NLP tasks such as sentiment analysis, sentiment parsing, semantic parsing, or spam filtering should remove stopwords, where tasks such as text summarization, language translation should not remove stopwords. To remove stopwords from a sentence, you can divide your text into words and then remove the word if it exists in the list of stopwords. So, in the below example, first we perform word tokenization to the sentence, and when we look at the code, we can see that we select every word in the token such that those words never occur in the stopword dictionary. So the output will be containing about the words that does not containing stopwords. As we can see, the stopwords like and, to, are, to, of are removed from the output. Next step is stemming. Stemming is the process of reducing a word to its word stem that affixes to suffixes and prefixes or to the roots of words known as lemma. Stemming is important in natural language understanding and natural language processing. It lowers inflection in words to their root forms. For example, the stem of the words eating, eats, eaten is eat. Stemming is desirable as it may reduce redundancy, as most of the time the word stem and their inflected words mean the same. We can implement lemmatization in Python language using NLTK Porter stemmer. There are also many other algorithms available for stemming. Okay, in this output we can see the stem for likes is like. Next step is lemmatization. It is the process of grouping together the different inflected forms of a word so that they can be analyzed as a single item. Lemmatization is similar to stemming, but it brings context to the words. So it links words with similar meanings to one word. For example, a stemming algorithm reduces the words chocolates, chocolatey, choco to the root word chocolate, and retrieval, retrieved, retrieves, reduced to the stem retrieve. To implement lemmatization in Python program, we have the library NLTK WordNet Lemmatizer. So here we can see in the output, rocks is converted to rock and corpora to corpus. The next step is part of speech tagging. POS tagging, it is the process of determining the part of speech of every token in a document and then tagging it as such. For example, we use POS tagging to figure out whether a given token represents a proper noun or a common noun, or if it's a verb, an adjective, or something else entirely. Some of the tags include FW for foreign word, NN noun singular, NNS for noun singular, NNP indicating proper noun singular, JJ for adjective, RB for adverb, etc. So we can implement POS tagging in Python using NLTK POS tag function. So after tokenization and stopword removal, we can apply POS tagging in these tokens. Okay, here we can see in the output we got Rajib as NNP. NNP denotes that it's noun, and also JJ means it's adjective, and VBP means it's a verb. So the next step is chunking. Chunking or parsing refers to the range of sentence breaking systems that splinter a sentence into its component phrases, noun phrases or verb phrases. It is used to get the required phrases from a given sentence. Chunk patterns are the patterns of POS tags that define what kind of words makes up a chunk. We can define chunk patterns with the help of modified regular expressions. So in this example, we can see that after getting the POS tags, the chunk grammar defined would select each single plural nouns with not more than one repetition, followed by personal pronouns with no more than one repetition, and again followed by the past verb tense with not more than one repetition. Anywhere in the text, a regex parser was used to parse the chunk grammar. The POS tags were passed with parse function method to print the chunk. We can see the output here, as in I told children I was tell, and they were selected as chunks. And the last step is syntax parsing. The syntax parsing subfunction is a way to determine the structure of a sentence. Syntactic analysis, also referred to as syntax analysis or parsing, is the process of analyzing natural language with the rules of a formal grammar. It is a technique by which segmented, tokenized, and part-of-speech tagged text is assigned a structure that reveals the relationships between tokens governed by syntax rules. Example by grammars. Grammatical rules are applied to categories and groups of words, not individual words. Syntactic analysis basically assigns a semantic structure to the text. So this syntax parsing can be implemented in Python using the NLTK Core NLP library. It is provided by Stanford University. So as you can see in the code, you can download these files from the Stanford website and apply Core NLP parser into the sentence, and we get the output as the syntax structure of the sentence. So in this video, we have discussed about text parsing, its relevance, and the important steps in text parsing. Thank you.